Okay, well, somebody said we got 25 over 144 here. I got a bunch of decimals. There's no way to compute or to relate the decimal, like 0.176 or whatever it is, to these numbers. You don't see it immediately unless you are a computational genius, okay? But this has a direct connection here, and it tells you something, okay? So there are always advantages to getting exact numbers. Now, if these numbers up here were 3.7295 and 48.35482, when you square them, they're not going to mean anything to you anyway, okay? They're not going to have a simple connection. But when you have a simple connection between these numbers and these numbers, you want to try to maintain it. And you can also do the decimal approximation as long as you use an appropriate number of significant figures. Okay, well, let's see. This is just this, right? How is it that this reduces to 25 over 144? I want everybody to write that out. Write out this expression, write out the details of how this reduces to this without crossing anything out, because I don't like cancellation. I despise it. Because people do it wrong. Now you guys are probably less likely to do it wrong, but I'll bet you if we did enough algebra, I'd find all kinds of incorrect cancellations. I certainly do on the assessments we do for our pre-calculus courses. I mean, both from students on campus and students off. I see horrible algebra. You want to do algebra from the basis of the rules, okay?
So you want us to just expand that out?
Well, I'm going to give you a little example of what I mean. Like, let's take 1/2 times 4/3. Now you're going to want to put a mark through the 2 and a 4 and write a 2 up there, right? That's expedient, and that would be correct. You would be doing cancellation correctly, but do you really understand what you're doing? Well, I kind of think you probably do, but I would rearrange this as 4 over 2 times 1 over 3. Okay? And then I would write that as in prime factorization. Okay? And then I could write that as this, which equals 1 times 2/3, which equals 2/3. And I didn't have to cross out anything, right? Now, one reason you want to do that is, I don't know if you've gotten into the theory of rational functions, but when you're dealing with rational functions, you know, people, I see it all the time, people will take something like x minus 4 over x minus 2, cross out the 2 and the 4 and get a 2 up here and get x minus 2 over x. And then they cross out the x's and they get minus 2. Okay? And the majority of people will do something like that. Now, I don't think the majority of you would, but if you get a little careless, it's easy to do something like that, right? Now, you don't have to get that involved with this because things rearrange pretty easily, but I want to see if you can rearrange this in detail without crossing anything out and follow all the rules. Okay? Just as an exercise in algebra. It'll drive you nuts, but it'll be good for your soul.